Welcome everybody. We are just going to wait for everybody to get on. Let's give them about 1 to 2 minutes and we'll be right with you. Hello everybody, my name is Jeanette Espino. I'm the director of the Imperial Valley Mesa program. Welcome to our cargo glider training. On today's training agenda, we are going to go over the competition overview. I'm going to share the new objective for the glider for 24-25. We will watch a competition video, go over the curriculum that is available to you. We will do a few simple activities that you could show, that you could work on with your students, and then share some glider concepts, and then we will be open for questions at the end. So every 3 years or so, we'd like to change up some of our projects and give them a new objective. It's not a big difference this year. I'll go over it in the next few slides, but as you will see, this year, students will design and construct a glider capable of carrying the largest possible weight while achieving the longest flight distance. So it's heaviest weight and longest distance together. Both middle school and high school will be going for distance this year. That is a change from previous years where sometimes it's accuracy for high school. Both middle school and high school will be trying for the longest flight distance. The new objective this year, as you can tell, it's still carrying a payload. This year, instead of ping pong balls, we are using hex nuts. And I'll show you a more close-up picture in just a minute. Middle school has a minimum of 2 hex nuts, that's minimum, and high school has a minimum of 10 hex nuts. Each additional hex nut over the minimum adds 2 inches to flight distance. So again, it's longest flight time plus heaviest weight. So for middle school, you would add 2 hex nuts minimum. If I would add 3 hex nuts, 4 hex nuts, 5 hex nuts, each hex nut gives me an additional 2 inches to my flight distance. Materials allowed. As per usual, any material is allowed, with the exceptions of hazardous materials or remote control devices of any kind and any additional power sources. As you will see in some of our videos that we will demonstrate, and actually I'm going to show you some gliders that we have made here in office. As you can tell, this is balsa wood. We're also using poster board for the wings. In addition to that, you will see this glider specifically in the video. This yellow addition here was 3D printed to hold the hex nuts. So do you have to use this? No, but it's a nice way for your students, especially those who have access to a 3D printer, to practice their design skills online and incorporate it into their gliders. We also have another glider here made out of balsa wood and poster board. This is only, the hex nuts are attached by tape only. Okay, for the obstacle, we did not change anything from previous years. It's the same distance, it's the same PVC pipe with the nylon string. And again, the glider must fly over the 5-foot obstacle and must stay within the 10-foot width of the obstacle as it's flying over it. So that remains the same as previous years. The one thing we did change is a little tiny bit, but for the better always, is the launcher. As I have mentioned in prior trainings, we really listen to the feedback that we get from teachers, from staff, from students. And one of the things that they really touched on was that the launcher had no inclination. So within our office, we have a real life STEM god, as we call him. His name is Minero, and he's always right behind me. Do you want to come say hi? Come say hi. Everybody has heard the name. Here's the man, the myth, and the legend, Minero. He created this little, very simple attachment. It basically, as you can tell in the pictures, it just sits, it goes right into the bottom of the legs of the front of the table, and it gives it a 5-degree inclination. It is deep enough to where you don't have to add anything else. It literally, you put it on, it gives it an inclination, and this does, it gives the launcher stability. If you, those of you that are returning teachers or students, we had some stakes that would go into the grass, or some PVC pipes that would go in the bottom to stabilize the table for launch so that it wouldn't rock or move or buckle. With this, it gives, again, the table a 5-degree inclination. It actually solves all of that. And we've tested it several times, both on the grass area and on pavement, and it stabilizes the table. So this is available. This link to print these is available in the rules. Also, we always offer, because we know that not everybody has a 3D printer, you can email us, and you will have our information at the end of this presentation. You can email us, and we can also print a few of these out and send them out to the school sites. If you don't have a printer, a 3D printer within reach. This is required for this year's competition, so please make sure that you have this at your competition. Okay, moving on to the payload. As I touched earlier, 6th, 7th, and 8th grade have a minimum of 2 hex nuts. Again, the very specific kind we are purchasing is, the link is on the rules. We are asking that you purchase them from Home Depot. The sizes are right on here, but also again on the link in the rules. We want everybody to purchase this exact hex nut so that it is standard throughout the state of California, and everybody is using the same hex nuts for the same weight, same size. So minimum of 2 hex nuts for middle school, maximum of 10 hex nuts for, minimum 2 hex nuts for middle school, minimum 10 hex nuts for high school. Each additional hex nuts adds distance to your flight distance. Let me see, anything else on the hex nuts? Oh, in terms of how you attach them, I touched on, for example, creating something that holds them. On here you can see a very simple picture with 2 hex nuts taped, and then on the other side is 10 hex nuts that are also taped. You can glue them on. And almost anything is okay as long as we can see the AAB marking. So when you check it in for Mesa Day for inspection, we have to be able to see this marking to see that it's the correct size. But otherwise, any type of attachment is fine. As I had shown you earlier, this attachment that was made here in the office, there's an opening here, and we can still see all of the markings on those hex nuts. We are continuing with the 3D printed launcher adapter. It is optional. You do not have to use it. If your student does not use, if your student chooses not to use the 3D printer adapter, that's okay. It will be available to you guys in Mesa Day. In our findings, when we practice here with them, it just gives the glider a smoother launch. It's easier to hook onto, but again, it's not mandatory. But regardless, there needs to be something like this carved in, or again 3D printed on your glider that will hook onto either the rubber band or onto this 3D printed adapter. This is the file. Again, it's in the rules for those of you who do want to have your student launch, or if the students want to launch with this. The 3D print file is in the rules for the launcher adapter. We are using the same rubber band as in the past 3 years. Again, it is very, very important that if you're using a brand new rubber band, that you prime it first. And that just simply means you're pulling it a total of about 16 pulls. So that then after the 16th pull, almost up to your 70th launch, there's a consistent launch because you've primed it to be ready for that launch. Now, with all of that information that I just gave you, we are going to watch this year's new objective video. It will show you everything from launching to the setup for the launcher and the obstacle. It's just a few minutes long, so please enjoy, and we will be right back. This is a brand new, really exciting resource that we have as of this year, and it's going to be an escape room. So if you guys are familiar with the math escape room that we used for Mesa Day, the same company put 3 escape rooms together for us for the 3 physical projects. So glider, moon base, and Mesa machine. So it's not 100% ready yet, but within the next few weeks, we will have logins available for all of our teachers. So you would get that directly from your center director. This is not a Mesa Day competition. It is to help the students prepare for the 3 physical competitions. So for example, this is the glider escape room. We worked very closely with the Brain Chase company as to what we wanted on here. So the students, while playing this game, will also learn a lot of the concepts that are used in the glider. I'm not going to go through the entire thing because you literally have to escape out of each room. But when you come here, you're going to see there's the Mesa gliders, Mesa machine, and the moon base. You would start the adventure, and it gives you about 59 minutes. The students should escape within about an hour. This is very, very much recommended that it's played in teams, not students on their own. The teacher should walk them through it, because if you just kind of set them loose, they will get a little confused. But that's all I'm gonna touch on. There we go. It comes with a little background music. So on here, you click on different things to get out of this room. There's 3 rooms. But again, this is all I'm going to talk about on this today. Ellen from Brain Chase will be on a workshop on Saturday explaining this, and I know you will also hear a lot more from this from your directors, from your specific sites. Thanks.
Hello everyone, this is Minero, and I'm going to take over for Jeanette and introduce you guys what the Mesa Advisor Resource Site is, the Mars site. So this is the Mars site, and it's going to be available for every single one of you. It is just a regular link, and we'll put it on a chat so that you can follow this with us. So if you go to the left side and you hit module, there is a lot of components, resources for those specific. There is introductory activities, and if I continue on, you will see the Mesa Day curriculum, such as a glider, Mesa machine, Mesa tag. So if we click on glider and we see this is what you guys have available for all of these projects, and each and every single project has something like this. So if we click on engage, there are guiding questions, introductory activities, and we click on explore. There's a whole bunch of PowerPoints about aerodynamics. We extend, elaborate. We see some constraints, budget, more information for you guys. So we just wanted to show you guys and everyone else that we have all this information for this specific project and any other project. So right now, pretty much we'll move forward and talk and show you guys the other video. Thank you so much, you guys.
Okay, so now that we went over the curriculum and what's available to you, we're going to show you how if I had a Mesa class or after school program, how I would introduce a glider. So we have in our office Michelle Jimenez, who's our academic coordinator. She's going to conduct a very, very simple introductory activity with you called the Ring Wing Glider. Let's welcome Michelle.
So thank you, Jeanette. What we're gonna do next is we're gonna do a small activity. It's called the Ring Wing Glider, and it's super interesting. You don't really need a lot. All you need is a piece of paper. Hi everyone. So today we're gonna do a very simple activity you can use to introduce gliders. And what we will be building is a ring wing glider. So all you need to build this glider is a piece of paper, piece of cardstock. I have a piece of cardstock because as I was building several of these, I realized that the cardstock flies better. But if paper is what you have, then that's good too. So what we're gonna do now is we're gonna start building our glider. So the first thing you're gonna do is grab the bottom right corner of your piece of paper or cardstock, as I have, and you're gonna unite it with the top left. So what you wanna do here is you wanna make these points as close to each other as possible, but you also want a 90-degree angle here. So to me right now, that looks about 90 and they're about the same height. So what we're gonna do is we're gonna crease it. We're gonna crease the paper on cardstock. And you wanna make sure these creases are like really tight. The tighter they are, the better your glider will fly because it will have less drag. So once we are here, you will fold the opposite side of your glider, and we're gonna fold it up about 1.5 centimeters. It just depends on how big or how small you want to make it. And this is what it looks like right now. Again, try to make those creases as hard as possible. So after we create the first fold, what we're gonna want is that this piece, this flap in the center, has to extend over the corners. So what we're gonna do is we're gonna fold it again. And now the corners extend. And again, you wanna try to keep those creases as hard as possible. So this is what your glider looks like now. And now we're almost done. After this, we're gonna rub this corner to create our ring wing. So after we rub the cardstock or piece of paper, we will have something that looks like a crown. See if you see it from the front. But what we want is this curvature here. So now the final step is to create a ring. So what we're gonna do is we're gonna take the corners and we are gonna put them together. And if you see, it kind of creates pockets. So all you have to do is interlace them like that. And see, mine fall apart. So I'm gonna try it the other way. And it doesn't fit because one side will always be larger than the other side. So we're gonna try it again to the other side, and then now it fits all the way. You can put a piece of tape if you like to hold it together. I didn't, and if you press it together as possible, you won't need it, but you know, that's always an option if you want to just make sure it's secure. And then this is what a ring glider looks like. This is what it looks like on the side. These are our wings, and it's a ring. So now I will teach you how to best launch it, is having the wings facing up. And that's our ring wing glider. Thank you.
Thank you, Michelle, for sharing that with us. And now that we did a very, very simple activity, we are going to move on to something a little bit, a little bit more in depth. We're going to build a very simple glider, but now out of balsa wood. It's not a competition glider, but it's just giving you those building basics so that your students can understand, and then from there build the competition glider. So please welcome Luis. He was one of our Mesa students and did work with us for a while, but he moved on to bigger and better things. So please enjoy this next video with him.
So we're going to start off first by cutting our fuselage at 10 inches. Using the ratio, this means that our wing has to be at 10 inches. And using the same ratio again, it's half that length, so it's a 5-inch tail wing. In order to attain symmetry, I like to do some lines to help out. So right here, as you can see on the fuselage, we got 3, which indicates a third mark and a center line. And both center lines for the wing, and just one center line for the tail wing. Now that we have the lines marked, I'll show you how to place them. We want to line up the center line of the wing to the 1/3 mark on the fuselage. and then the center line with the center line. And now you just gotta line up 2 lines, and that's how it would be placed. Tail wing is a bit easier, it's just both center lines, you line them up, and that's how it should be, towards the rear of the fuselage. But before we put it together, now we gotta talk about airfoil and angle of incidence. This piece provides the airfoil, and at the bottom we have the angle of incidence, which provides the angle. And this one is ideally placed between the wing and the fuselage. And this is how it would look. Now we have everything glued together. This is how it looks. Right now we're going to do a quick test to make sure we're symmetrical. We're going to check our 90-degree angles. As you can see, the tail looks pretty straight, and now our wing seems to be straight as well. Now you can see I added some more airfoils to keep the curve throughout the whole wing. This is essential as to create more lift. There is the angle of incidence. Now, in order to increase stability, we're going to add a fin in the back. This will help it fly more in a straight path. It's kind of like an arrow. Now it's all placed. Now we're ready to do the finger test for balancing. So as seen before, we're going to put it in the center right there. And as you can see, we need some weight at our nose. We add it at the nose just to keep our total weight low. And as you can see, now that we try to balance, it tips now to the side. Now we would just add a little bit more mass on the opposite side, furthest from the fuselage. As you can see, now it seems to be way more balanced. Now that we have a new adapter, we'll show you a quick tip of what we believe is a good way to attach your glider to the actual launcher we have. So you just cut 2 pieces of the fuselage as shown. It's a really good shape that will really grab onto the launching mechanism. As you can see, this is how it should look, and that's how it grabs on. And now once it's glued on your glider, it's ready to be launched.
Thank you, Luis. Okay, and again, bringing back Luis and now Paola. This is a video that we've shown a few times over the past few years, but it's actually, I think, one of the most important pieces in this presentation. It really helps your students understand a lot of the concepts. It helps them kind of problem solve as well. If it's gliding to the right or to the left, what can I do? So it just gives them a lot of good information. This little cutout part is also in the rules because I think it's really important that the kids have just direct access to it. I can't tell you how many times over the years I've had students come up to me at regionals and they recognize us from these videos and tell me, you know, how many times they watched it and how it helped them. So please remind them that this is available to them in the rules. It's great if you have a MESA class to just sit and watch it with your whole classroom so that they can understand the concepts. So let's bring on now Luis and Paola, who will do glider concepts with us.
Today we'll go over some few concepts and tips that will hopefully help you out with this competition.
To build a glider, we first need to understand how it balances itself in the air. Some of the forces that it's going to experience are going to be thrust, drag, lift, and weight. These forces are going to be shown in the image below.
The most important force is lift because it is the force that counteracts the weight of the glider and keeps it in the air. A way to manipulate it would be with the airfoil or the angle of incidence.
When we talk about airfoil, we refer to the shape and arc given to the wings of a glider. By adjusting the arc, we can create more lift. However, it is important to consider that when we create an aggressive arc, we are also creating drag. In the following diagrams, we will show you different variations of airfoils.
Needless to say, moderation is crucial, especially when we talk about the angle of incidence. The angle of incidence is the inclination of the wings in relation to the fuselage.
The center of gravity is ideally placed at the center of the wing. This is important because it helps reduce torque forces in any direction, which cause the glider to flip.
To ensure that our glider is balanced, we will have to do the finger test. We will place our finger on the center of wings and check for balance. If it tilts a certain way, we would put weight on the opposite side until it is balanced. In our case, we'll be using clay, and it is preferably placed at the tip of the fuselage.
Although drag is an opposing force, it ensures that you have a stable flight. To be more specific, you will achieve a straight path. Now, when you locate most of your drag on the back of your glider, it ensures that your tail follows your nose. Now, let's not forget that too much drag will shorten your flight distance. For any object in the air, any square or sharp edges are usually not your friends. Rounding your edges will help you achieve a smoother flight. Some tips to make your glider more aerodynamic would be to round your edges like so.
Typically, we want the fuselage and wings to be the same length and our tail wing to be half that length. Then we would place the wings at the 1/3 mark on the fuselage and the tail wings towards the rear of the fuselage. Then, in order to attain symmetry, we can use an imaginary line going through the fuselage and make sure both sides are mirrored throughout. This ensures that the forces are proportional. For a more stable flight, try to place your load at the bottom of the glider as it will prevent wobbling, fighting the urge to flip over. The balls also come with some surface area which create drag. This drag is inevitable, but we can use it to our advantage by placing it far from the nose. Another way to decrease drag caused by the load is to line them up in the lines as in a way to reduce cross-sectional area. Another way is to wrap the balls in a way that helps it cut through the air.
There are a few other ways to improve stability in our glider, and here are some examples.
The first example we're going to talk about is the winglets. As you can see on either side of the wing, we have the winglets. Those help with the straight path. Then towards the rear of the fuselage, we have our tail wing right there, which helps also with the straight path. And right there you can see the airfoil that helps in order to reduce drag and have more lift. Now we're going to go into something called a dihedral. As you can see, the wings are bent upwards. This helps balance the load that it has.
We want to emphasize that before you launch, it is important that you have a good center of mass and a symmetrical glider.
This is crucial because you want a predictable flight to be able to diagnose any problem you may confront. Also, avoid any unnecessary crashes.
And now that we have a symmetrical glider and a good center of mass, then we can start launching. One of the first problems that you're going to encounter are going to be when your glider pretty much tips like this or does a backflip. To counter this, we can add more weight on the front or create more lift on the tail.
It's also important to note that you don't have an airfoil or an angle of incidence that is too aggressive. Now, if your glider keeps crashing down, a good solution would be to try to remove some weight from the nose and hope that fixes the problem. If not, you can look back to your airfoil or angle of incidence and probably increase it.
Now, if you find yourself making excessive adjustments, you might need to reduce the total weight. Finally, if your glider is turning, you can simply add more weight to the other side to fix this problem.
Another solution could be maybe adding more stability components as a bigger tail, or maybe some winglets over here by the wings.
Next, we will answer some of our most frequently asked questions. The first one being, where do I place my hook?
For an adequate launch, you would typically place it under the center of your wings, and it will be launched parallel to the table. But if you push it back a bit more, you can probably get a better flight as it will catch the air better.
Our next question would be, how do I adjust my glider to weather conditions?
So our launching mechanism has a few adjustments available, such as direction, pitch, and roll. We will now go over some tips for middle school students. To remind you guys of your goal, you would want the maximum flight distance possible. To obtain this, you would want to reduce drag as much as possible, add many stability components to get a straight path, and when launching, get an efficient launch by reducing friction and get all the power transferred into your glider.
Now for high school, remember that your objective is to overcome an obstacle while carrying 4 ping pong balls and landing on a specific target. Accuracy. Some of the tips that I have for you would be to not be afraid of lift. Remember that you're carrying a heavy weight and it will help you, gain height. Another tip that I have for you would be to launch the exact same way every time. That way, you're going to be eliminating variables. And lastly, I want to recommend that you build a very sturdy glider, because remember, the heavier it is, the faster it's going to crash. And you want to spend less time fixing your glider and more time adjusting for accuracy.
Okay, and as we finalize, these resources are available to you, again, within the Mars website, and then you have it here. Everybody will receive this presentation. They will also send the video to you guys. It will be up on our Mars site, so please use it as much as you need. So within the resources, these are just a few other things that we have for you in case you want to go into gliders a little bit more in depth. And that concludes our glider training for today. We will ask you to fill out a survey in just a minute. I will put that into our chat. But now we will start on any questions that you might have.